In this video, we're going to look at a distance problem. And in one, it says, at noon, a van and a car leave the same intersection traveling in the same direction. The van is traveling at 30 miles per hour, the car at 45 miles per hour. At what time will they be 9 miles apart? The picture below helps to visualize the problem related to distance. The first thing they want us to do is choose a variable to represent the unknown. And the unknown in this case is time. The question was, at what time will they be 9 miles apart? So we're going to use t, and we're going to say t is equal to the time it takes for them to be 9 miles apart. And then in the next question they ask is, what is the same for both the van and the car? And the thing that is the same is that they both leave at noon. And then it also asks, is it distance, rate, or time? And they both leave at the same time at noon, so the time is the same. And now to fill out our table, we have the van's rate, they told us was 30 miles per hour, and the rate for the car was 45 miles an hour. And we've said that the time is the same for both of them, so we're going to call both time t. And now they want us to set up some equations. Distance is equal to rate times time. So I'm going to say the distance for the van, so I'm going to subscript my d with a v for van, is equal to rate times time, or 30 times t. And my distance for the car is equal to the rate of 45 times time, t. And now they ask, how are the distances related? And we could say that the difference is 9 miles. And now they want us to write the equation modeling the problem. So if we need them to be 9 miles apart, we're going to do the distance of the car minus the distance of the van, and this is equal to 9 miles. So now we have DC is 45t, and dV is 30t, and this is equal to 9. And then we do 45t minus 30t, we get 15t is equal to 9. And now we'll divide both sides by 9. So t is equal to 9 over 15, which is also equal to 3/5. And the units that we're using are miles per hour. So this t is in hours, so we could say that this is equal to 0.6 as well if you prefer decimals. But the time is in hours, so it takes them 3/5 of 1 hour to be 9 miles apart. And if we wanted to convert that to minutes, we could say that there's 60 minutes in 1 hour, and we want to multiply that by 0.6, or 3/5, and that's equal to 36. So it's 36 minutes and 0.6 hours. And now they want us to check our answer. So we're going to use our distance of each car. So we have the distance of the van is equal to 30 times t, which is 0.6, and this is equal to 18 miles. And then we have the distance of the car in the time, which is 45 times 0.6, and that's equal to 27, and both of these are in miles. And then if we did 27 minus 18, it is equal to 9. So the difference between the two is 9 at the time, 0.6 hours, or 36 minutes. So then to state our answer, we're going to say the car and the van will be 9 miles apart at, and now if they left at noon and it took them 36 minutes to get 9 miles apart, then it would be at 12:36 p.m. And that's all for this video on distance problem example 1.